Jeff, you have been tasked with designing us a proper septic system. We have no town sewer. Can we use a conventional system here?
No, we cannot, and I'll explain why. We have a conventional system here. We have the house here. The flow from the house is going into a conventional septic tank. The solids are settling in the tank.
This is the tank I've always understood. Yep. Solids and liquids come here, settle right to here. Bacteria breaks it down. The liquid, the effluent, leaves this way and goes out to the leaching field.
Correct.
So is that what we're going to use here?
We can't use it on this site because of the Adams property is in a critical resource area.
Okay, what does that mean?
That means it's in a environmentally sensitive area, and because of the coastal ponds, the salt ponds along the south shore, we have to use a denitrification system.
Because that's the big issue, nitrogen?
Nitrogen.
Okay.
So we have to reduce the nitrogen going into the groundwater.
So how do we get around that?
Well, first off, we have the house here. We have a similar type septic system. Then it goes into this second baffle of the tank. It goes into a pump. It pumps up onto this Advantex pretreatment unit, which has hanging sheets in it full of bacteria. The bacteria change the type of nitrogen that's in the system. It flows down into this tank and where the actual denitrification takes place. So the denitrification takes place down in the septic tank. Mm-hmm. So it flows through here 3 to 4 times. At each cycle, only a portion of the flow goes out to the leach field.
So how much lower will our emissions of nitrogen be for this system versus a conventional?
It's about 80%.
Wow.
Yeah, so it's an 80% reduction in nitrogen.
Right. So what do these membranes look like?
I have one over here.
All right.
This is a hanging sheet. It's a textile fabric. There's 2 courses of it.
And there's more than one in the...
There's a number of these in there,
okay,
in the pod. And the effluent is distributed across the top of these evenly.
Right.
It just sort of wets the surface and drips down.
And this is just loaded with bacteria?
It's covered with bacteria. The bacteria love this.
And the bacteria breaks down or converts the nitrogen?
Converts the nitrogen to a different type of nitrogen.
Okay.
And then a portion of this, most of this will go back to the septic tank.
Yeah.
And a portion of it will go out to the leach field.
And keep on knocking down that nitrogen level?
Yes.
So does this type of system mean we can change the size of the leaching field?
Yes, we can. Conventional field has a 4-inch pipe.
Oh, yeah.
And it would have 2 holes in it.
Right. Some water dribbles out here, covered in stone.
Covered in stone.
Yeah.
But in this situation, we can use a smaller pipe.
Wow.
With very tiny orifices.
Look at the size. That's it?
Yep, these are the orifices,
Wow.
1/8-inch holes. And they're about 2 feet apart or 15 inches, depending on the size of the system.
All right.
And that's it.
All right, so where does all this equipment go on site?
Let's go take a look at the site.
All right, you're on.
So could these homeowners have even considered reusing that cesspool?
No, they cannot. They do a substantial improvement to the house. They have to replace the cesspool.
All right, so our drain line leaves at the basement level right out to here, right?
Correct. Well, sort of, but it comes over from this corner a little bit more.
Okay.
And then it comes down, it's at the basement level, comes down here to the septic tank.
Septic tank's right about here?
The septic tank's a little bit lower, it's down in here. It's 5 feet by 10 feet. It's got 2 24-inch covers, and it's got a large flat cover as well. It's about 3/4 of the size of a sheet of plywood.
Will it stick up or?
It'll be flush to grade.
Okay, great. And where's the leaching field?
Let's go down, I'll show you.
Okay.
Okay, the effluent will come down from the septic tank and it'll come down into a small pump chamber here.
Right about here, okay.
And then from here, it's going to get pumped up to the disposal field or the bottomless sand filter. Okay. The bottomless sand filter is about 10.5 feet by 20 feet.
Now that's amazing. I mean, a typical leaching field is 30 by 60, 70, 80. This is really small.
Yeah. No, these are one of the advantages of these types of systems is they're very small and compact.
Yeah.
That's why we use them.
Great.
The system's partially above ground, as I said, and there's going to be timbers around the edge and there'll be stone on top. That's all you'll see.
Landscape around it a little bit?
You can landscape around it to hide some of the timbers if you'd like.
So what's the next step?
Construction.
I'll see you when there's a hole in the ground.
Okay.
Thanks for watching. This Old House has got a video for just about every home improvement project, so be sure to check out the others. And if you'd like what you see, click on the subscribe button to make sure that you get our newest videos right in your feed.